So we have Professor Rob Dempski from chemistry giving his perspectives here.
Thanks, Andrew. It's great that he could start talking about the material that we've been working on together. But I'd also like to thank a number of individuals on campus who've been able to help us through this work. And that includes Sia Najafi and Mary Beth Harity, of course. Without them, they would be instrumental. But if I can have the next slide. I should also note this is part of a longer series of work where a few years ago we developed augmented reality protocols to teach lab safety in Goddard. And you may be familiar with this room. And these are just screenshots using the HoloLens. The top image on the left shows equipment such as the telephone or exits. And what we built was a program where students could walk around the lab. In fact, the same woman that was shown with HoloLens in Andrew's presentation is there on the bottom slide, and she can narrate things that are important in the lab. While we originally intended this to be a standalone, with the advent of the pandemic, it's now possible to have this program be recorded or in live person, and then have students be able to get the same experience that students in the lab are getting. If I can have the next slide, please. Now, as part of this, it's important to have easy control. And so this is just to remind me that, in fact, faculty who are in charge of this program can readily change things in the program to be able to set different equipment at different parts of the lab. So therefore, if there's 3 exits or 4 exits, for example, you can put things around the room. And as I noted before, those items count down. So students can walk around and really either in person or remotely gain experience about what is happening in the lab. So we've been pretty excited by this. And in fact, we're really repurposing it from a paper that we had a few years ago. Can I have the next slide, please? But moving forward, we also knew that we wanted to create improved content for our lecture courses. And so for those of you who may be familiar with protein structures, really understanding the 3-dimensional structure and spatial characteristics of proteins is very important. And so along with my colleague, Jose Aguelo, what we did is we, on the fly, put together a program where students could build their own 3D structures and then import them into a commercially available program called Augment. Now, this was kind of our quick and dirty mechanism to be able to show things. And in fact, this image is really showing, it is off of the program itself. And although it looks like it should be from a computer, the background is really a wall in our house as we were trying to put a paper together. So what happens is students can build these programs, they can share the structures with each other, and then they can walk around them in any location they want to be able to get a better understanding of the 3-dimensional structure. In this case, it's a potassium channel, which conducts potassium ions across the membrane. And so what we've been interested in here is identifying those purple circles, which are the actual potassium ions, and understanding how the protein interacts with those potassiums. So we found this to be a really effective manner to be able to have students learn how to understand the spatial characteristics of these types of proteins. Next slide, please. However, because we were bootstrapping really an existing program which wasn't intended for protein structures, there were lots of issues. For example, we couldn't change coloring or we couldn't change the format. And so what we've wanted to do is move forward and improve our capabilities, and how can we have a new program with what we actually want to do. So fortunately, we have right now, if I could have the next slide, and if you could start the video on the right, Claire, who you're going to see in the background there, has within these last few months been building a new program to visualize protein structures in 3 dimensions. So what we're going to see here is, in contrast to before, as you can see highlighted on the left, and then we'll see it appear all of a sudden on the right. These protein structures are essentially being downloaded directly from the protein data bank. We can see them at different sizes. We can see them next to each other. And as she changes the image right now, you can see that she can change the different visualization tools, so we can get a better sense of different conformations and how different shapes may affect related proteins. So together, we've been able to have improve both by de-densifying and having at-home learning for both the lab as well as lecture-based courses.